explain to the audience, I know this is a big topic, but rope access.
Oh my goodness. Thanks for making a small topic.
Yeah.
That
Yeah.
really helps to narrow it down, Phil. I
Yeah.
appreciate that. So rope access, it's funny because historically people will think of rope access as like literally anything to do with ropes, right? So if you're hanging on a rope, it's rope access. That's not necessarily true. So rope access is the term that has been chosen to describe a certain type of fall protection that also involves access. And so rope access in its definition, according to standardees, like according to ANSI and ISO and then the standards organizations, and rope access is any two rope system in which one rope provides the means of access and egress, and the other rope provides safety backup, and in which the primary and secondary ropes are interchangeable. So I can put my primary system on my secondary rope and vice versa at any point throughout, while always maintaining at least 2 points of context. That's the simple boiled down definition of rope access. Now, rope access is used in a bunch of different kinds of environments, right? It can be used for any number of people. Oh, rope access, that's what window cleaners use, or that's what rock scalers use, or that's what bridge engineers use. And all of those are true, but that's not all they use. It's just one of many types of fall protection. So you could compare it, for example, to fall arrest is another type of fall protection. Positioning, restraint are all other types of fall protection.
Awesome. Could I get you to elaborate a little bit on, because I've got this written down, the differences, the nuances between full protection, full arrest, full prevention, full restraint? All of these words have the fall in them. And I know that can overwhelm people when they hear, especially with new standards in our industry, OSHA standards around work at height, that some of these can get very overwhelming for people. And we've got lots of people, our clients, who are, what's the difference between these? Full protection, full arrest, it just feels a lot of language, but maybe you could illuminate us.
That's a really good question, because so often I hear these terms being used interchangeably. People just make an assumption that fall protection equals fall arrest. For example, if I've got fall protection, it must mean that I'm working in a harness, and if I fall, I'm attached to a dorsal attachment, and I might perhaps be caught if I fall. That's not necessarily true. Fall protection is generically, in the big picture, fall protection is anything that protects you from a fall. So it might include a safety rail. So if you can't fall because there's a safety rail in the way, that's fall protection. It might involve restraint. Restraint is a type of active fall protection. So let's look at those two different things first. We have active fall protection and passive fall protection. Active fall protection is something that requires you to do something, like put on a harness, attach to something. Active fall protection is different from passive fall protection, because passive fall protection thinks for me. It's the handrail, the safety rail that's already there that prevents me from falling, unless I'm doing something ridiculous like crawling over it, but we won't go there. So active fall protection is further divided into certain types of fall protection. So restraint is a type of active fall protection that prevents me from reaching an edge where I might fall. So it's essentially a leash. You put a leash on so the person can't reach the edge. Positioning is a type of fall protection that allows me to maintain a position on a slope, like a roofer working on a steep roof. He's going to lean into that fall protection. He's going to lean into the positioning system so that he maintains his footing. But if he falls, if there's a chance of him falling, he should also maintain another true fall arrest system, so that in the event of the failure of that positioning system, he is caught. So what's this fall arrest of which we speak? Well, fall arrest is anything that arrests or catches your fall in the event of a release of the main system. So if the main system is your feet, a fall arrest system will catch you if your feet fall off of the ladder, for example. a fall arrest system can also be a passive system, which is a little bit confusing to some people, but there is such a thing as a passive fall arrest system, and it might include netting. So under a bridge, for example, if people are working on the edge of a bridge, there might be a net system that prevents them they might fall 20 feet, but they get caught by this net. So active fall protection, passive fall protection, and are kind of the key terms. And fall protection in general is anything that protects you from a fall.
So essentially, there's this umbrella of like fall protection, and then underneath this umbrella is the different methods by which we prevent or protect people from a fall.
That's a fabulous way of looking at it, Phil.
Thank you. What you mentioned that those words get used interchangeably. Where do you see that being an issue? Because I think that even people listening to this might be like, "Oh, is this just legalese?" Where do you see, what's the importance of understanding these definitions from your perspective?
Well, as an employer, it's very important to understand that OSHA requires that we provide fall protection to anybody who's working at height. So OSHA, or the Occupational Safety and Health Administration, says of any employer, if you have employees who are working at height in a hazard, you have to protect them from that hazard. So as an employer, there's a number of things that I might be able to choose as methods to protect them. And so that, as we talked about the methods of fall protection, each one of those methods has different rules. So fall arrest, for example. In a typical fall arrest system, OSHA says that I'm not supposed to let someone fall more than 6 feet. So I have to catch them within that 6-foot range. Now, that's a pretty simple definition, and there's definitely more to it than that. But that differs from a positioning system in that in a positioning system, I'm supposed to be leaning into the system and not falling at all. So knowing how to build the systems, how to rig the systems, and how to keep those systems compliant and safe for the employee is critical to understand the terms.
Mm-hmm. You were involved, I know that you were involved in some of the standards that you were speaking of. One, I asked the question because I'm kind of intrigued myself. What was that process like? And I'm sure the answer is in not the positive, but how maybe was that process?
It's funny.
And what do you see from going through that process that is the importance of why this needed to have occurred? I understand that there were incidents that led into this, but where do you see the benefits on some of these standards that have come into place in the recent years?
Let me start by saying that I am the original anti-standards person. I am that person that says, hey, train your people really well and give them the tools and resources they need to do their job and leave them alone. Let them go do what they need to do. And so from that perspective, the concept of standards rears its head, right? Mm-hmm. And the reality is that OSHA, right, has standards. OSHA has regulations, and whether we like them or not, we have to meet those standards. We have to meet those requirements. And so the way that most people meet ANSI or OSHA requirements is by using ANSI standards, which are a little bit fuller. They're a little bit more detailed. They have the how-to, whereas the OSHA regulations basically say, here's the limit, here's where the line is, don't cross it. And ANSI standards kind of define that and say, well, here's what they mean by that line, and here's how to not cross it. And here's the kind of equipment that you need to use, and here's the limitations that you need to place on a system, and that sort of thing. When I was first asked by my employer to get involved in standards development, I laughed. I was like, and his response to me was, well, Loui, if you're not sitting in that room, somebody's going to be. And so which would you rather do? Have somebody who doesn't like standards and doesn't want over-standardization to be sitting in that room, or to have somebody who's excited about being able to write rules for other people sitting in that room? And I thought about it and said, great, when do I start? So in reality, there's all of us sitting in that room. Now, a lot of people believe that people, safety through engineering, right? People shouldn't have to make decisions. People shouldn't be allowed to make decisions. Everything should be standardized to the point that there's no variation, there's no deviation. And if we can do that, everybody will be safe. I don't know about you, Phil, but that's not the world that I work in. My world is not a standard world. Everything's different. The places I work every day, the kinds of structures I'm working on, the kinds of environments where the ropes that I manufacture are used, all of that, it's different all the time. So how can you use a standardized system to build a safety program for a non-standard environment? So for me, the important thing about developing standards is that the standards need to be measurable. They need to have some criteria by which you know whether you're in or out, but not so specific, not so design restrictive that you have to do it. You have to connect, carabiner A to anchor B the same way every time. So that's where this is a really roundabout answer to your question, I know, but what happens in the real standards environment is that there are people sitting at the table who believe on opposite ends of that spectrum. And so there's this kind of constant push and pull. And that in reality is what standards are. Standards are where everybody gets their perspective and everybody inserts their perspective, and you pull on it a little bit like a tug of war. And as my friend Steve Hudson used to say, a good standard is one in which everybody is a little upset. So it's true consensus when everybody's just a little bit upset. And if we can have those people who are so specific and they want everything to be defined down to the nth, and we can balance their needs with the people like me who just want to provide information and let people go do their work, I think we end up with a decent standard.
Well, I'm going to thank you for being a part of that, because I'm also of the mindset, we've had discussions internally before around our involvement in different committees or joining different things. And I've had that same thought around, well, if we're not there, then somebody else will be. And then we don't get to complain after the fact, because we had this opportunity to maybe be there. And,
That's right.
And so I thank you for being there, because I know that the stepping into those processes aren't easiest. And I'm almost guaranteed, just in this brief conversation and the small conversations we had at ACCT, that you brought in a lens that was very valuable. And even just being somewhat a little bit anti-standard, I think is probably the best person to be in the room. I don't know if people who love standards should be there.
I agree. I'm going to give you an example, Phil. This is an interesting one that comes up a lot because rope strengths are measured in different ways. So if in different industries, commodity ropes, for example, the strength of a commodity rope is not measured in the same way as a life safety rope is today. That wasn't the case when I first started in rescue. I won't say how long ago, but all these ropes were coming in. It was like, well, this rope, look how much stronger this rope is than that rope is. It's like, wow, this one's rated at 5,000 pounds and this one's rated at 7,000 pounds. How they're the same size rope? Why is that? What's the difference? Well, come to find out, at that time, there was no consistent way to measure the strength of a rope with any kind of statistical significance. So breaking strength might be the manufacturer pull tested a rope and the number that he came up with is the number that he put on the package. Or a manufacturer might test 10 ropes and the best number he came up with is what he put on the package. Or maybe he was really conservative and it was the lowest number that he put on the package. Or maybe it was somewhere in between. There wasn't any way to know it. There was just no consistency in that. And so the Cordage Institute wrote a life safety rope standard to help differentiate this, because in the Cordage Institute in those days, rope strength was measured by mass per unit length. So if a rope was X, weighed so much per meter, the assumption was that it was so many pounds strong. And so they wrote a standard for life safety rope that really kind of brought all of that together. And they said, okay, well, you have to do at least 5 tests on this given rope, it needs to, and you need to measure or calculate 5 standard deviations below the mean breaking strength of the tests that you performed. And then you need to report something at that strength or lower as your, that's the highest breaking strength that you're allowed to report as the minimum breaking strength. So now, all of a sudden, there's some consistency. Now we have some sort of constant with all the manufacturers who subscribe to that standard, who all of those manufacturers who say, yes, I make rope according to the Cordage Institute standard. Now you know how they're measuring their strengths, and it's not just an arbitrary number.
Yeah, my stance, is it on standards and the creation of standards, at least for the industry that I'm working in, and it's because the industry isn't particularly old. It's, but it also hasn't had much oversight. So I could see that when things came in, the need for us to be wearing full body harnesses at height, and I could see the resistance. You could hear it. It was very palpable. And I think it was because the assumption was, well, I've been doing this for 40 years and I've never dropped anyone, or I've never, it's just these individualized stories of, well, I've been fine, therefore we should all be fine. And I think that with this awareness that those who are nervous around standards are those who might not be hitting those marks anyway, right? Like that's where maybe that resistance comes from. And I can say that, like, I've found that working at height in a full body harness is far more comfortable than I ever was wearing a sit harness. So the improvement just in terms of those things, I think are really important. But I do agree that notion of overall consensus, because therefore we've all got the same benchmark. These benchmarks allow us to be able to then improve the benchmarks or work off them. And we have language that is similar. Without similar language, that's also where you can get this isolation and siloing effect, where one organization's doing one thing and then you go to somewhere else and you're like, wow, doing it something completely different, yet we speaking similar languages.
That's foundational to any kind of conversation. I mean, safety, of course, but any kind of conversation. If we're not speaking the same, mean the same thing with the same words, then we're kind of got no hope.
Absolutely. I know that for you as well, training is a big part of this, right? The education of this is such a big part of it.
Absolutely.
Where do you see, or how much information, I'm going to say specifically for you, are you giving in terms of training when it comes to this? And I mean it in terms of, I think you talked about it. We do this a little bit, the thinking practitioner, aka you could look at a site and be able to adapt to it. Because you said yourself, there's no clear defined, you're going to go to the same place and see the same thing, right?
That's right.
How do you teach that? Because we get in this mindset of like, how do we teach thinking practitioners? Not, I don't want the answer to be because Phil told me or Loui told me, right? Like
That's right.
How do you teach that?
This is one, Phil, where man, I've wrestled with this over the years, because from the beginning, like, I've always believed that in order to be safe at height on rope with rigging systems, I mean, if you're doing fall arrest or just a non-thinking system, then okay, whatever, the rules and you know how to use them. But if you're doing any kind of rescue, rope access, anything where you actually have to think about your systems, then you dang well better understand exactly how those systems work, what happens when they don't work, what are the consequences of failure. You need to understand where your weak points are in the system. You need to be able to analyze your systems. And so I've always been of the belief that people should understand concepts. So if I have a descender, it's not that it breaks. It's not that it, as in B-R-A-K-E. It's not that it breaks me down the rope. It's not that it provides friction. It's open that sucker up and see how it works. And why does it make friction? And if it's not making the right amount of friction, why could that be? And how would you analyze that? How would you even think about it if you were in that predicament? And so understanding why your gear works and what happens when you attach that descender to an anchor or to your harness, and what are the physics at play, and what's going to cause it to malfunction, and what are the things that you don't want to do and why, and all of that's so very important. And then I started to run across people who they're doing well just to understand where to attach it, right?
Yeah.
And you can't teach everybody the concepts. Everybody is not, there's an aptitude that people are naturally ingrained to do something or another, and some people are really good at maths, and some people are really good at English, and some people are really good at rigging, and they're not always the same people. And so I've had to come to learn that, and I've had to come to the point where, in an organization, it's probably a good thing to have a standardized system. It's probably a good thing to have, this is how we do it. You attach carabiner A to anchor B, and you put your lanyard here, and this is what it looks like when it's wrong or when it's right, and anything other than that is wrong. So within an organization, I think it's super important to have that level of, I don't know, is that training even the word? That level of understanding. But for a true technician, for somebody who's going to be making systems, somebody who's going to be designing systems, somebody who's going to be deciding whether that system that somebody else just made is safe or not, I think understanding the physics behind things is super, super important. And I know that word physics scares people, and it's really not, I'm not a scientist, but I love physics, right? Because I love ropes, and I love gravity, and I love height, and all those things. When you put them together, guess what they create? You're right in the middle of some principles of physics, and you'll understand physics really, really fast, whether you know the words or not. And that's where I think experience is absolutely essential. Doing a couple of things wrong over the course of your life, and hopefully you survive it, right? You have all your systems backed up, and you have your principles in place so that when you make mistakes, A, you catch them, and B, your system catches you. And understanding is experience. And without going through that, I don't think people can really grasp. I don't think that just learning from a book or learning in a class, here's where you attach and that's how you attach. I don't think you can get it. I think that has to be some tactile, some time on rope, some time with your feet in the air.
I think this lines up as well with the two words that are jump into my mind when I think of these things, because I've racked my brain around. I was having a discussion with another trainer about how much information do we want to give, and how much do I bring to the table just because I'm a nerd about something, right? Like, I even at a very basic level, I used to teach the history of belaying because I loved the mechanics of the technology change, and I think that informs why we do things a certain way.
Yeah.
But for a new person who just is being sent to a belay training, all of that is over their head, right? Like they don't want it, and in fact, that could be negative to their learning. And now they're
it's going to overwhelm them, isn't it?
And so I think about these two words, and I know they apply also to standardization and OSHA, but competency and qualified. Someone who's a competent person and is a qualified person. I wonder if you could speak to those, like what those words actually truly mean, and maybe how that even applies to some of the training.
It's interesting. OSHA actually likes those words, and OSHA has come up with some definitions that are used pretty much throughout the working world, regardless of what industry you're in. These generic definitions pretty much apply, and actually they have three words. They have authorized, competent, and qualified. And in OSHA speak, authorized simply means that you're allowed to do a job. So I, as your employer, have given you enough training that I believe that you can go out there and do a job. Not think, not make any decisions, but just do what you've been taught to do. Competent, OSHA defines as someone who has enough experience and training to be able to recognize a hazard when they see it, and to take prompt corrective action. So in practical speak, we would often think of that as maybe a supervisor, right, on the job site. But that's that person who, he may not know how to design a new system or how to fully even rig the big picture, but he understands it well enough to be able to recognize it when it's wrong and to take prompt corrective action, even if that action is only to say, everybody out of the field, everybody out of the pool. That's competency. And then qualified is defined again in regulatory speak as having enough experience and education relevant to the topic at hand. So you can be any of these things in rigging, but you can also be any of these things in driving a boat or, whatever, driving a forklift or whatever. Authorized, competent, and qualified. Qualified would be that person who has enough knowledge and experience and training specific to the field that we're talking about to be able to design systems and create systems and to decide how those systems should and shouldn't go together, what kinds of equipment is appropriate for use in those systems and what is not. Some people in work at height safety consider that only a professional engineer can be a qualified person. Now, that's not necessarily true in OSHA language. OSHA doesn't necessarily say that, but some of the standards do in ANSI, and there's kind of an underground belief among, I guess I should say, among engineers that feel strongly about that. But my belief is that anybody who is going to be designing and building challenge courses, anybody who's going to be has enough knowledge and training to design and specify the type of fall protection that's going to happen in that challenge course. Those are all qualified people. They're qualified by virtue of their experience and training specific to that industry that, many a professional engineer wouldn't comprehend if they walked on site. So that just by virtue of the world that you live in, the world that you work in, it qualifies you to that level.
Yeah, I think that's, at the conference, there was a big discussion around qualification. And I specifically for me, in terms of the trainer role, like what qualifies me to be a trainer. And I think that when we look at that language, the ability to be able to look at a scenario and be able to figure out the process by which we could solve said problem. From a trainer perspective, I think it's an interesting one. You talk about the engineers in qualification on a challenge course. Our industry essentially started with engineers building courses and then being like, oh God, we have to teach people how to use these, I guess, but not having any experience on how to educate. And
exactly.
So I think that there's been this shift almost in the training world of our field where a lot of trainers now come with an educational background and not an engineering background. And so even for myself, I don't build or design the courses that I train on. So I don't know the exact physics and mechanics of how the structure is designed, but I do know every component of how to solve a problem on that course. So, and I also know how to teach other people how to do so. So there's this nuance of like, how do we truly define what that might look like for me as a trainer versus someone who is an engineer or builder?
And that's a fabulous point, because it kind of speaks to that thing of by virtue of training specifically to the area that you're working in. So again, just by being a professional engineer doesn't mean that somebody is a qualified instructor, and vice versa. And so to be this concept of authorized, competent, and qualified, I might be at a different level in different environments. I might not be very comfortable at all in a paper mill, but if I go on a tower, I'm going to be a lot more comfortable. And so my level of ability to make decisions and rig and to know what I can rig to and what not, that's going to vary largely depending on environment, not just according to how long I've been in the industry and how many ropes I've chewed on.
Yeah, the phrase, I've been in this 40 years, therefore. You could have been really bad for 40 years.
Well, or you might have been doing the same thing every day for 40 years. It's like if you're doing the same job all day every day for 40 years, then you've kind of got one day of experience 40 times over. But if you've been working in different environments and different kinds of situations, and then your experience is going to count in a little different kind of way. And how do you qualify that? How do you measure that? How do you quantify it? That's the hardest thing, I think, in just about every industry. In some industries, in the rigging industry and in like theater and entertainment rigging, they actually have and I don't know if it's the whole industry, if it's just this one particular place I was working with in Los Angeles, but they actually have a passport type book where you get a rubber stamp in, okay, well, this person has now worked in this kind of environment. Now this person has worked in this kind of environment. And so, whether you're deemed competent in different kinds of situations that are common within your industry.
Well, in a previous episode, and I'm not sure when this one's coming out, so I'm just going to leave it like that and cut this part out. In a previous episode, we talked about professional development for practitioners on a challenge course, and we kind of encouraged people to seek outside of just their niche. So even as I'm talking about this, I am internally very desperate to take a training with yourself at PMI, because just on rope access, because there's a whole overlap, but there's stuff that will not be applicable. But I just think the overlap is the part that I'm more intrigued about, and even the process of training. I think that there's philosophy in training that I'm kind of intrigued to watch other trainers do stuff and just say, wow, I'm going to take this or whatever. And I encourage other people, as you're listening, not just saying I want to go there, but I would encourage yourself to reach out and take some training with PMI. Just because even if you're an educational, traditional, dynamic, belayed course like what we might be, I think the overlap between even the discussion on some of these things around full protection are so important, because the greater your understanding, the more broad you can be in this qualified mindset of being able to make choices and decisions. Like I have a colleague who's a very accomplished rock climber, and he has knowledge of certain things that I don't have knowledge of, and he can bring that to the table. And I think that I think is very exciting as I'm talking to you.
It is. I think that one of the most exciting things that I get to do because of my unique role in PMI, we serve so many different markets, right? I mean, we serve the rope access market, we serve bridge engineers, we serve rescue people, fire departments, SWAT teams, rope access teams, cavers, climbers. I mean, and to be able to connect with all those different people in their respective environments, and to be able to go on jobs with people in different environments is like, wow, I can take this and apply this there. Oh my goodness, why did we never think of that? It's so, to me, that crossover in knowledge and understanding is huge. And you can you can take this out if you so choose. But I'll just mention that there's a annual event called the International Technical Rescue Symposium, and it's held every year in a different location. It's underwritten by PMI and CMC, but it's not commercial in any way. Basically, all of these people come together. It's limited to under 200 people, so only a maximum of 200 people are allowed to come every year, just to keep the dialogue intimate, if you will. And people present on everything from I had this incident happen and here's what happened, and hey, what do you all think? Or hey, this really cool new device came out and I know it's not designed for this, but guess what I did? I tried it in this manner and it worked. Isn't this cool? And I mean, just all these different presentations, and they're all from different industries. Like there's rope access people there, there's cavers there, there's climbers there, there's mountain rescue people there, there's fire departments there, there's industrial rescue teams there, and they're all sitting there in the same room and presenting during the day and asking each other questions. And then at night, everybody hangs out together and they go to dinner together and they come to the hospitality suite and discuss things. And to me, it's information overload for 3 days, but it's the most exciting 3 days of the year for me, because there's such knowledge and such depth and breadth of experience in all these people, that to have it all come into it's giving me goosebumps even now, to have it all come into the same room at the same time. It's just, it's cool. It's really exciting.
Well, save me a seat, Loui.
Nice.
So